talk about inverse functions. So we've got our functions, the vertical line test, all that stuff. We're going to talk about inverse relations or maybe inverse functions. Some relations are functions, some aren't. The main idea here is if you're trying to find the inverse of a function, you're going to flip x and y. Everywhere you see an x is going to become a y, and that's because what we're really finding is the line of reflection will be y equals x. You flip the inputs and the outputs, and it ends up being a reflection over a line. We're not going to do as much graphing yet. Right now, I want to do one just to kind of give you the idea. It says, make a table for y equals x squared. And I'm just going to pick some easy numbers for x squared. And what we'll do is we'll say, all right, look, let's start here. 0 squared is 0, 1 squared is 1, 2 squared is 4. Negative 1 times negative 1 is also 1, and negative 2 times negative 2 is also 4. So you can see there's some symmetry here. This is the graph of y equals x squared. Okay, I'm going to just put those dots on there, and I could add 9 as well, 3, 9, negative 3, 9. So this is the parabola. That's y equals x squared. I kind of missed that one. But now we're going to flip this, and we're going to now look and see what we get. We get 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. If I flip my x's and my y's, so my x's become my y's, we have a different function here. 4, negative 2, 1, 2, 3, 4 negative 2's right there. 1, negative 1, 0, 0, 1, 1, and then 4, 2. And if you look, what you've got now is a parabola on its side. Okay, now that's not a function because it would fail the vertical line test, but that is the inverse relation for y equals x squared. So these are called inverses of each other. And what we're going to do is actually look at this, and you might realize that if you get rid of this part, if you ignore those guys, this is the square root of x. So a parabola, half of a parabola is a radical. Let's do this algebraically. So if I said find the inverse of y equals x squared, first out, write the original one. Now I'm going to flip x and y. So x equals y squared. And to solve for my inverse, if I wanted to solve for y, I would square root. And when you square root both sides, you get the square root of x. Now, if you want to keep this a function, you don't include plus and minus. So if you look back at our graph, if I just say y equals the square root of x, that would be the inverse function. So we would have to get rid of these guys because they're going to be repeats. Okay, so this is the inverse relation or inverse function. You flip x and y, and then you solve for y. So let's try this one. Flip x and y, x equals 2y minus 4. And now I'm going to solve for y. So to do that, move the 4 over. X plus 4 equals 2y. And then divide everything by 2. So you could write this as just x plus 4 over 2. But when it says write it as an inverse, that's why I like to write this as f inverse. Well, these aren't functions, so we'll just leave it alone. But you could write it like this as well. F inverse is x plus 4 over 2. When we get to the function thing, maybe we'll start to write it like that. But main idea is these two are inverse functions of each other. I flipped x and y, and I solved for y. Do the same thing here. Flip x and y, x equals negative 3/4 y minus 10. So we're practicing equation solving. Add 10. X plus 10 equals negative 3/4 y. And similar to what we've been doing with the exponents, if you're trying to get rid of negative 3/4, multiply both sides by the reciprocal. So negative 4/3. And I'll just write this as negative 4/3 x minus 40 over 3. You can put a plus there if you want, but that's the inverse. Okay, distribute. 4/3 x, 4 times 10 is 40, so we'll just leave it 40 over 3. Couple more. Flip x and y. X equals 5y plus 1/2. Now to solve for y, you move everything that's not a y on the other side. X minus 1/2 equals 5y, and then divide everything by 5. So I'll just leave it like that. X minus 1/2 over 5 is fine. Last one, flip x and y, 2/3 y plus 1. Subtract 1. And then to undo multiplying by 2/3, multiply both sides by 3/2. So that goes away, and you can just write it as 3/2 x if you want to distribute, 3/2 x minus 3/2. Okay, we could have distributed there too, but it's fine. They're both correct. All right, those are linear functions. Those are pretty easy. When we get to power functions, we need to know a little bit about our exponents. So I'm still going to flip x and y, but now to get y squared by itself, I'm going to add 1. Fine. And now to undo squaring, we're going to square root both sides. So the square root of x plus 1 is y. Now that's the inverse of this. Same thing here. X equals 2 times y to the 3 halves. Now we got to follow the steps here. Subtract 3 first. And now to undo, multiply by 2. We're going to divide by 2. So you have x minus 3 squared, or over 2, equals y to the 3 halves. Now the last step is to get rid of that y to the 3 halves. We're going to take both sides to the reciprocal, which is 2/3. So this is x minus 3 over 2 to the 2/3 power. That'll just get you y, because those cancel out. So that's the inverse function. You can write that as a cube root, because it's third root. Last couple. X equals the square root of y minus 1 plus 2. First, get rid of the plus 2, so now it's x minus 2, subtract 2 on both sides, and then to undo square rooting, you square both sides. So x minus 2 squared equals, on the right side I have y minus 1. Last thing, add 1. X minus 2 squared plus 1. Should feel a lot like when we were solving these. When we were solving radical equations, we had a lot of those. And then we'll do one more. X equals the cube root of 2y plus 5. So to undo cube root, you need to cube both sides. X cubed equals 2y plus 5. And now to get y by itself, subtract 5. Those aren't like terms. And lastly, if you have times 2, divide everything by 2. Let's just leave it as x cubed minus 5 over 2. That's the inverse function. Oops, can't see that. There you go. Okay, so is that it? Yeah, that's it. That's finding inverse functions of power functions. We're going to practice this a bunch, but you definitely need to be aware of how to move between powers and roots going back and forth with these rational exponents. So try the practice problems. Make sure you hit that like and subscribe.